revision, mathematics revision, that is Form 4 mathematics. Um, the book that we are going to be using to guide us in this revision so that we keep up with the syllabus is this. So the book is the famous book that most of our students are used to. This particular picture, this particular page, most of our students who are taking Kenya's Certificate of Secondary Education are familiar with this particular page. So, courtesy of Datalytics Academy, I'll be taking you through this book beginning from page 1 as I begin today, and it will be consistent up to the time that will be done with the entire syllabus. So I urge you to get close, subscribe or follow, so that whenever I have these such presentations, you are available to take advantage of them. Or you can also follow me whenever I'm live here on Facebook. I'm also live on YouTube, so you can also subscribe on my YouTube channel by following the links on my Facebook. You are able to find the link to our YouTube channel, and also by extension to our website. Now, for now, what I want to do is to take you through a cursory look of what we have, a cursory tour. I want to take you through a tour of what uh, Datalytics Academy is. So I will come here and do that. Then yes. So we are logging in. So we're already there. Now, once you get here, you'll realize that we have a lot of goodies for you. For instance, if you visit our homepage, there may not be much, but it guides you on how you get access to our page courses, and to some extent it also gives you an opportunity to interact with our products like the newsletters that we produce on a regular basis. It also gives you a chance to browse through some of the courses that we give emphasis to, and that's just that. Then I would come here and talk about courses. There are quite a number of courses that will depend on your choice. So you'll notice that once you visit, we will be able to give you uh, direct access to our course menu. You can contact us through this. Our main office is located along Kisumu Mwani Road. This is the email address you use, and that's the phone number that you can use to reach us. So I'll be posting what I call a brochure or a catalog of the courses that we have soon enough. Now, another page that I want to talk about very fast before I move to the main reason why I started this video is this. So this page of consultancy provides a wide range of services both to students and professionals. So it's a consultation page that allows you to contact us because since so they are consultancy and data driven insight. So you partner with Datalytics Academy for rigorous analytics, financial modeling and research support that turns complex data into clear decisions. We blend academic depth with real-world analytics to support exam preparation, institution planning, and strategic decision making. So this page is a page for for academic consultancy and also industrial consultancy. What I would call in a blanket term, professional consultancy. So that's that. So there's much that you can gain from by visiting this particular site. There are a lot of services we offer. If you're a student who is taking masters or PhD or bachelor's and you're stuck with data analysis, you're stuck with the approach on how to design your questionnaire, do the chapter 3, the most what mostly we refer to as the chapter 3, the methodology part. Please contact us. We'll assist you with the necessary tools so that your thought is captured in terms of data, and we give you a meaningful result. So up to there, I want to get to the main business, the main reason why I'm here. And the main reason why I'm here is uh, this particular book. So for our learners who just exited Form 4 or who are just about to join Form 4 and have started interacting with this particular book, you will be familiar with the kind of information that I have I'm presenting before you. So I want to get to matrices and of transformation. And then what I want to do before I start interacting with that, let me get our whiteboard. And well, I'll pick a new one because I want a new page. And then I start with blank. Of course, I want to make it look like old school board. Then I'm here. Okay. Now, for the sake of being neat, we have to be neat. So I will have this. I bring it here. I suppose that should be the middle. Then that's thick. Let it be there. Yeah. Yes. So I have that. Sorry. I have that. So I want to start. Yes. Now I want to start making sense of what we have. Yeah. So now our whiteboard is ready. You can see. Now we have a platform where we can interact. So I can say matrices and transformation. Matrices and transformation. So that's the first, that's what we want to look at. That's the topic as you have seen it. Just a minute. I said you want to be neat. Yeah. So it's just that as we had it. Yes. Yeah. So we have that matrices and transformation, and what we had is this. So we are told that a transformation changes the position, size, or shape of an object. Examples of transformations include reflection. So I would do this. Let me bring this here so that we don't lose track of what we are doing. Let's this to occupy the better part of the other board. Yes, so we are here. Good. Yeah. So we are told that it changes the position. So such transformations may include, we are told, will include reflection. So it means one thing we want to look at is reflection. The other one is rotation, as we had seen, rotation. And yet another one is We have rotation and we have enlargement and translation. Enlargement, enlargement and translation, and translation, and translation. So basically these are the major components that we will be looking at. So what we are saying, that given a shape, given an object, we are able to perform several aspects of transformation, as we have seen. We may have reflection of the object, we may have rotation of the object, or we may have enlargement of the object, or a translation. In which case, a reflection is where we'll be considering a defined mirror line, so that the image is reflected or kind of replicated on the other mirror. Then on rotation is where we may change kind of orientation in terms of direction, in terms of direction and that is defined by the coordinates in vector form, as we had seen. I know you had covered vectors in form 3, and so position of objects are defined on a Cartesian plane or on a Euclidean space using positional vectors in terms of the positions, in terms of the x, y, z coordinates. Then enlargement is where an object can shrink or or actually expand, like what we normally have as model bottles of, say, for Coca-Cola, etc., model cars before they are taken to the market. And then we also have translation. So all these aspects we are going to look at, and that's the purpose of this particular topic. So this was an introductory aspect. I just wanted to introduce this so that we know that this exists. For those who are interested and would want to reach out, I want to say that I'll be having these sessions every morning on Saturday at such a time. So I want to briefly look at the first bit of it before I pen off, as I prepare the lessons for the coming weekends. So what I want to look at is the first bit that I should have cared to look at. Let me just, I'm trying to make it shrink so that it fits, so that I can clearly see it. Yeah. So this is what I have, matrices and transformation. And we see that consider, so this is the first example. Consider a triangle PQR. So we are considering a triangle PQR. That's the triangle we have. And with vertices P1, 2. So I would want to say at P we have the coordinates 1, 2. At Q we have 3, 2. We have 3, 2, 3, 2. And at R we have, just a minute so that we are able to move in sync. Sorry. Yes. Yeah. So I'm trying to have both on the same page without having to lose one. I'm just trying to see if this will sort us out well. Let's see. Looks that we are better. So do we need this? No. Okay. So R we can see is here 3. R is 3, 3, 5. R is 3, R is 3, 3, 5. R is 3, 5. So those are the positions that we have. We have all this. P is 1, 2, as we have. Q is 3, 2, and R is that. So the position vectors of the points P, Q, and R, if remember what you did in vectors in form, say in form 3, you'll remember that the position vector of P will be represented by OP, and we give it that because it's a position vector, and it will be 1, 2. And then the position vector of OQ, which will be given by 3, 2, as such. And finally, the position vector of OR, which is given by 3, 3, 5. Is given by 3, 3, 5. Is given by 3, 5. As such, those are the position vectors. So these position vectors are 2 by 1. They are 2 by 1 in the sense that when we are using that kind of reference, we do it in terms of row by column. So there are 2 rows here and 1 column. So that's why we call it 2 by 1 matrices, and can be pre-multiplied by any 2 by 2. So we are saying that any 2 by 1 matrix can be pre-multiplied by a 2 by 2 matrix. Now what we mean by that is, let me show you what that will mean. I hope we have captured this part. So I just want to show you that what that may mean. Yeah, because we are told that the position vectors are 2 by 1 matrices and can be pre-multiplied by any 2 by 2 matrix, can be pre-multiplied by any 2 by 2 matrix. So let's have a 2 by 2 matrix. If I have a 2 by 2 matrix, good. If I have a 2 by 2 matrix, a 2 by 2 matrix, say 2 by 2 matrix, say A, B, C, D, like that. And then I have any 2 by 1 matrix in the name of F. No, not necessarily. Let me get better. Let me just get better. I just want to get a direct one like P, OP now. I want to multiply it by OP, which is 1, 2, which is 1, 1, 2, just as direct as such, 1, 2. So in this case, it will be A times 1, A times 1 plus B times 2, because it's row by column, B times 2. So it will be B times 2, like that. And then the lower part will be C times 1, C times 1, like that, plus D times 2, D times 2, D times 2, D times 2. So in other words, this product will be A plus 2B. This is because this is A, this is 2B. So we'll be having A plus 2B, A plus 2B, and here we'll be having C plus 2D, C plus 2D. So you see we have multiplied. So pre-multiplying means that we have brought a 2 by 2 here. So here we said can be pre-multiplied by any 2 by 2. So we see this is a 2 by 2 matrix. This one here is a 2 by 2 matrix. This is 2 by 2. Let me see. Yes. This is a 2 by 2. but this is a 2 by 1. Yeah, this is a 2 by 2, this is a 2 by 1. So you see that a 2 by 2 has pre-multiplied a 2 by 1. Pre-multiply means the matrix becomes before. It comes before this other one. So that's how we get that. Now, these position vectors, what we can say is that consider the effect of pre-multiplying them by matrix. So it's just what I've had. So what I'm going to do is I want to get just to that specific example. I want to substitute the values given. I want to substitute the values that are given. Like here, I see that the values that are given are, we are given a matrix A. So consider A. What if we had a matrix A instead of having AB as I said? So we have A being just a moment, let me just set up myself well. Yeah, I think this will now be soft enough. Okay, now, so A is now, we are told is -1. A is -1. Oh no, this is now up. Just a moment, I'm just trying to set up the Wacom so that it works well. Should it be on this pad here? Okay, let me try here. All right, so we continue. So consider matrix A, and that A we are given to be entry. The first entry is -1, -1, and the other one is 0. Then we are given 0, we are given 1 as such. So that's the matrix A. We are expected to pre-multiply it with the position 1, 2. So in that case, that will give us pre-multiplying will give us this, so that I will now be having negative of 1, 0, 0, 1 as such, and then the position vector of OP was 1, 2, this. So what we have had is just what we did here. See what we did here, multiplying this by this, then that by that. Now I've substituted these values. I've now given these symbols actual values. So what we have is that if you multiply -1 by 1, you get -1, plus 0 by 2, you get -1. So the result here is -1. That's what we have. So here the value is -1. That's the response. And if you multiply 0 by 1, you get 0. Then 1 by 2, you get 2. So it means the second entry is 2. The second entry is 2. So you see that by pre-multiplying by this, we end up with a new position, -1 and 2. Let's see what happens doing the same with other positions. Like, okay, let's say now we have -1, 0, 0, 1, like this. Then multiply 3 and 2 as such. So you pre-multiply 3 by 2, positional vector 3 by 2, you pre-multiply it by the A matrix. So this will give us -1 times 3, -1 times 3 will be -3, plus 0 times 2, which is 0. So I get -3. So what I have here is -3. So here is -3. -3. We all agree that's -3. Then again, I have For the second entry, there is 0 times 3, then 1 times 2. There is 0 times 3, then 1 times 2. So here we have 0 times 3, that is 0, then 1 times 2, that is 2. So I end up with 2. So that gives me 2. That gives me 2 here. And that's what you can see the other hand, negative 3, 2. So this is the new image of the position vector 3, 2. That's the new image of the position vector 3, 2. Perhaps let me get to the new image of R. As we see, so you have seen how we get this negative 2 is just pre-multiplying this by this, giving you negative 1 plus 0 by 2, that is just 0, so we get negative 1. We come here, it is 0 by 1, that is 0, 1 by 2, which is 2, we enter the 2. We come here, it is negative 1 by 3, that is negative 3, plus 0 by 2, which is just negative 3, then 0 by 3, which is 0, then 1 by 2, which is just plus 0 is 2. So let's get the image of R, and that should be, so let me just remove this, and this is what guided us. That was the first guide we had, because we had values as such. So let me, yeah, yes, yeah. So let it be that. So for 3, no, for R, for R we have, negative 1, 0, 0, 1, like that. And the position vector of R was 3, 5. So this one here will be negative 1 times 3. So we'll be having negative 1 times 3 plus negative 1 times 3 plus 0 times 5. 0 times 5, like that. The second entry will be 0 times 3, which is 0 times 3 plus 0 times 3 plus 1 times 5. 1 times 5. If we work this out, we should be getting negative 3 plus 0, because we are now have negative 3 plus 0, and then 0 plus 5. 1 times 5 is 5. So the new, that is Q prime, is that. Q prime will now be negative 3, 5, as shown here. So maybe let me now enlarge this so that you see what plotting such points would mean on a Cartesian plane. And if they're plotted, this is the resultant figure. The resultant diagrams or object and the image are as shown. So they are as shown. So what we have here is that this was the object. This was the object as was defined before, with P occurring at 1, 2, occurring at 1, 2, Q occurring at, say, 1, 2, 3, occurring at 3, Q occurring at, let me just confirm what they were. Q occurring, the initial Q occurring at 3, 5, occurring at 3, 5, occurring at 3, 5, occurring at 3, 2, 3, yeah, occurring at 3, 5, let's see. The initial Q occurring at 3, 5, and then the initial R occurring at, just a moment, I need to be clear about, because I can't see. I want to be sure of what I'm saying. So we scroll here and see. The initial one was occurring at The initial P was 1, 2, then 3, 2, and 3, 5. R is at 3, 5. 3, 2, and 3, 5. 3, 2, 3, 2. This is, yes, here. Yeah, this is better. This is better. Now we can see. 3, 2. So we see 3, 3, 2. That's where Q is. R is at 3, 5. And P is at, so it's at 1, 2. That is for the initial object. But now, upon applying the transformation by the matrix A, by this particular matrix here, we applied a transformation by using this matrix A, where A is negative 1, 0, 0, 1, these entries. Now that has led us to a new image that now we see here, where now the new position of P is reflected. So this is a reflection. It's a reflection because we see the mirror line is actually the y-axis. The y-axis here is the mirror line. So P has moved on the other end, the end with the negative entries of x. So P, new P is this with the new entries negative 1, 2. New Q with the new entries negative 3, 2. New R with the new entries negative 3, 5. So we see this object here using this, applying the matrix of A is equals to negative 1, 1, 0, 0, 1. We end up defining an image. We end up defining an image of this object, which is this. And if we look at it keenly, it is a reflection on the line y-axis. So let's see. Example, identify the transformation whose matrix is. So first we want this. We are asked, identify the transformation whose matrix is this, this, and that. So let's see. Let's see what what that will be. And as I've shown you, I've already seen that the first transformation here was a reflection. So let's see the transformation that will be the type of transformation that we will have if we apply this. So we need to take an object figure and pre-multiply it with the transformation represented by each of the matrices. So let us take triangle ABC with vertices this, this, and this. So we'll be trying, the next assignment will be uh, applying these matrices, the matrices that are suggested here in example 1, the matrices suggested here is identify the transformation whose matrix is. So the matrices we are given are this, and we want to see their effect on objects. Having seen their effect on objects, then we'll be able to say whether it was a reflection, it was a rotation, it was a translation, or it was an enlargement. So up to there we see this. Where's my board? Yeah. So what I'll do, I think I need to clean this board so that we set out on the next exercise. Yeah, that's better. So sorry, I want to first start with A, and A is 0, negative 1, 1, 0, like that. And we are told that the matrix, the object ABC, is given is given by A, B, C. So 1, 1 would mean x is 1, y is 1. B, 3, 1, position vector is that, x, y, then 3, 4. That's the matrix. So let's see its effect. We'll have 0, negative 1, then 1, 0 as such, and then have here 1, 1, then 3, sorry, then 3, 3, 3, 1, 3, 1, then 3, 4, 3, 4 as such, then 3, 4. So let's see what we get if we multiply. Then it will be 0 times 1, which is 0, then minus 1 times 1, which is minus 1. So the first entry here is minus 1. The second entry will be 0 times 3, which is 0, then minus 1 times 1, which is just minus 1 again. The other part will be 0 times 3 times 1 minus 4, which is minus 4. So here I have minus 4. Then 1 times 3, no, 1 times 1, that is 1, plus 0 times 1 is just 1. We just have 1. 1 times 3, that is 3, plus 0, we just have 3. 1 times 3 plus 0, we just have 3. So that's what we get if we use that. Let's use B. B, if we use B, it will be 0, B was what? Okay, 0, 1, it's 0, 1. Okay. So B is 0, 1. B is 0, 1 and 1, 0. Then we bring in 1, 1, 3, 1, 3, 4, like this. So we multiply. It will be 0 times 3, which is 0, then 1 times 1, which is 1. Here the entry is 1. 0 times 3, 0. Then 1 times 1, we have 1. 0 times 3, 0. 1 times 4, we have 4. 1 times 1, 1. 0 times 1 plus 0, that is 1. 1 times 3 plus 0 times 1, that is 3. 1 times 3, 0 times 4, that is just still 3. So this, and so that's that. So I have 1, 1, 4, then 1, 3, 3. Let's see the effect of C. We then need to see the effect of C. Let's see the effect of C. So C is 1, 0, 1, 0, then 0, 1. 1, 0, then 0, 1, and we still have the same object. 3, 1, 3, 4, as such. And so this by this, we just have 1 here. Then this by this, we'll just have 3. We are doing that because this is already 0. So any term multiplied by 0 will be 0. Then 1, then this is 3. This is also 3. This is also just 3. Then 0 times 1, that is 0. So again, we'll be having 1. Then this by this is again another 1. Then this by this is 4. 1, 1, 4. So those are the entries. So we see those are the entries that we have. That transformation A gives us object with the entries -1, -13, -43. Transformation B gives us the image 111343. Then transformation C gives us the image 1131 and 34. So we want to identify the kind of transformation that those kind represent. So I want to see, these are the entries that we have. So you see, that's how we ended up with having this. So this by this, that is 0, this by this -1, as we have had them. So these are the images under those transformations. So let's see. The object and image figures in each case are shown in figure 1.2. So figure 1.2 is this. And we first start with the original image where we have 1, 1, then 3, 1, then 3, 4. Then 3, 4 as such, being translated, being transformed, being transformed as such. You see, now B, under the new transformation, we see new image where A is at position -1, 1, B is at position -1, 3, and C is at position -4, 3. And if you look at this, if you look at this object, let me take this highlighter. Let me highlight. If you look at this object here, oh no, select how do I go about this now? Underline. Yeah, let me just go with that. If you look at this object, where is it? Okay, if you look at this object here and this image, you see that there's a kind of, it's not a reflection because you cannot define a mirror line, and it's not an enlargement because this object is the same shape as this. Of course, the position has changed. So in this case, it's the position that has changed. The size has not changed. The shape has also not changed. So this is likely a rotation, and we'll in future want to see it is a rotation of what kind of orientation in terms of angles. So that is that for now. But let's come here. We then see that there is a new object. We now want to relate. Now we had the A prime, B prime, etc. So the transformation A, this is what it did. It gave us what we see is a rotation. We don't suspect this is a rotation. Then B gave us this, where the original is A, B, C, but it then now gave us the image as A prime, B prime, C prime, this one here. It's now mapped out this. From this, it has given us that. So what is that transformation? Now, this third one, that is part C, has actually mapped the image on itself. It has mapped the image on itself. It means by pre-multiplying it by that particular matrix, nothing has happened. So part C, straight away we see that's an identity matrix. So, and that we had seen because whenever you have such 1 0 0 1, that's an identity matrix. It means that it gives you what you started with. So we started with 1 1 3 1 3 4, and we end up with 1 1 3 1 3 4 as such. So that's an identity matrix. Now, from figure 1.2, we can see that the matrix 0, -1, 1, 0 represents a positive quarter turn about the origin, i.e. it's a rotation of 90 degrees or -270 degrees about the origin. We'll see what that means, but that's just what it is. Then 2, this one now represents a reflection in the line yx. So let's see. The line yx, if we were to define it, goes like this. It's actually this, the line yx. So if C, the line y is equal to x, the line y is equal to x. So if x is 3, y is 3. When y is 4, x is 4. Like that, like that, like that. If y is negative 1, x is negative 1. So that is a reflection represented by this. But now the third one is an identity matrix. It takes the object back to the original position. So that's what it is. Now I want to stop here for now, and I'll continue from example 2. Because these videos I'm also preparing for the online classes. We want to move as scheduled. So that is it for today. We introduced the lesson as such. So next time I come, I'll be continuing with example 2. So up to there, I say thank you, and you join me next time, such a time. uh, for continuation of that. Thank you.